friction. We went over this topic. As you see in the friction, friction has that coefficient has two regions, a static region and kinetic region. So what does it mean? When your part is stationary, is not moving, it's gonna use this coefficient, right? Another thing is that you see the friction resistance increases to a certain point. So this is where it's going to be maximum. When you get to that point, you have a friction resistance, some loss. This is going to be a loss. So you will have less resistance against moving the part. What does it mean? We had animation. Let me bring it up again. We have this animation. It shows, when you are. So we have, let's say, medium level friction. The surface has maybe 0.2. Friction is not too much. And then we have this weight. We want to move it, right? If you apply, 50 Newton horizontally, so this person is applying 50 Newton in X direction, right? Positive X. What is the friction resistance? So it is not at that, maximum level yet. The maximum, so this is the friction force. It's somewhere here, right? So you apply that more, force 50, and then because we didn't get to this point yet, the part is not going to move, right? I told you we can, calculate this maximum force by equation. F is mu times n, right? N is the perpendicular force. Let's say you have this weight, right? This box, and it has W, right? So N is going to be the perpendicular force to the surface. So you have this N, the mu for every material, we have a certain number. They provide that number to you, 0.2, 0.3, 0.4. You put that one in there, N for this situation. Yes?
So mu will always be defined within the problem? It will always be given to you? Is this for the material, right?
Yes. No, I showed you a table for every material. For example, steel to a steel, we have a certain number. For aluminum to a steel, there is a different number. Sometimes, not for this class, you want to find, which friction is going to be best for your problem. Then mu might be unknown for you. Then you can find it, based on that, friction resistance. You can choose, let's say aluminum to steel might be good for your design, right? But for this class, we will provide that in mu. Okay, so you solve this, Fy 0, and then you find W is going to be N, right? You bring that, W, let's say, 10 pounds. Mu, we give you 0.2, let's say, and then 10. So this is going to be 2. Friction force will be 2 pounds. Example. Okay, so this person applied 50 Newton. Let's say the maximum is around 140. We can find it later, but we are here. So the friction force, applied force is 50. Friction force is 50, right? So the part is not going to move, correct? So let's increase it until we get to this point. You see, still it's not moving. Doesn't move. I'm going to apply, So when it comes to this point, the maximum, the part is going to start moving, right? Because this is kinetic, mode, kinetic region, motion region, this portion. This is a static. Okay? So what happens when you get to this point and it starts moving, the friction force is going to drop. It's going to come to this area, this portion. Let's see what happens. So still we have, not moving. So applied force is 126. Initially, you saw it was 126, 125, right? It was not moving. When we get to this point, now this is 94. Because we are in this region now, right? We passed this. The friction force dropped, right? And then summation of force is going to be 32, in the y, x direction. Let me do it again. So the criteria, the maximum force is 125, I think. 125. You see, even I am lowering my force, my part is not staying. It's moving because we are still in this region, right? So I have to come to the the simulation stopped. So because I'm going to restart, make it 0. Now we're going to start from 0. $125. If I add one more force, it's going to start moving. So 125 is right here. See? They start moving. You see the difference? So let me make it. What is the friction force at this situation? 50. So we are not at the maximum level yet. When we say what is the maximum force to move the part, you have to use this equation. So the maximum force this one gives you this value, right? How about this one? The friction force, 100. So it's going to be same as, how much force you apply, right? So let's go back to that presentation. We had. So in the friction application, we use this equation. We're gonna skip this part for this class, for this course. We focus on this three equations: summation of forces in y direction, summation of forces in x direction, and F friction force will be this. This represents the maximum. And we are focusing, for this lecture, we're going to focus in this area. Now, whenever we give you a value, friction coefficient, that means, this coefficient, not this one. Okay? So this is, for maybe next semester, others. Okay. So we had this problem where it was asking, we're gonna solve the first part again because we had some, miscalculation in the second part. What does it say? We have a 400 block. It's supported by a horizontal floor, right? The coefficient of static friction mu s between block and floor is 0.4. Calculate the force P to cause motion to impend, right? That means, what is the maximum, you need to use the maximum friction force in this problem. Find the force so what is P? Calculate force P that is required to cause motion, right? When the P is applied horizontally. So it's pure X. Okay, we have this equation. You can use this equation, f of y. Whenever you have a problem, write these equations down so you don't forget to use them. And you know what options you have, right? Okay, I can pick, let's say P, right? P is going to be in horizontal direction. I use, fx0 P. What do I have in x direction? What component do I have? I have P itself, right? And friction. Remember, it said P is going to be in this direction, right? We want to move the part in which direction? Positive X. Positive X, right? So if you're going to move the part in the positive X, friction resistance always is going to be against movement. If your part is going to go this direction, the friction is going to be against it, right? So that's why F, this is the friction resistance, it's going to be opposite direction. You cannot have P in this direction and friction resistance also in this direction. So it's not going to be actually, right? So the reality always F is going to be against movement, against movement. Okay, P is a positive, F is negative. Do we have another force? No. 0, right? So P will be friction force, right? So what is friction force? Friction is mu S N, right? What is mu S? It's given, right? 0.4 times N. So we need N, right, everyone? Okay, what other option do we have? So I use this one, right? I use this one, we can use it. Fy 0. What do we have in Fy? Negative 400 pound. And then plus N. My N is 400. So I was looking for this one, right? P. P is this, P is F, and then F is a function of N. So I can make it like this, right? 0.4 times 400. It will be 160 pounds. So I use all these three options, tools to find my required P. So that is the minimum, force. Minimum force to move this part. Okay. If you apply 170, it's gonna move. If you apply 150, it will not move. Right? The force has to be more than 160. Okay, so that is when your P is complete, horizontal. But how about we have a scenario that we have angle. In that condition, your N will be impacted. The perpendicular force will be impacted. Because that is impacted, the friction force will be changed too. Because friction change is a function of perpendicular force. Find P when you have P with a 30-degree angle. So again, we have these three options, right? You can pick any one. Let's say we can use this one, Fy0, right? What do we have in Fy? In previous problem, we had only W, right? And N, this two. So N was exactly same as this 400. But now you have P. P has angle, so it has some component in Y direction, and some of it is going to be in X direction, right? So then you can decompose a P, Px, Py. What else we have? N here, and then we have W. What is Px? Px will be, this is 30, right? Will be P times cosine 30. Py P sine 30, right? So now we can build this one, W minus W, which is 400. Then we have plus N. We have what else? Minus P, which is point half 0, right? Because I'm gonna make N. I'm gonna keep N here, and the rest goes there. So add W. So this is gonna be 400, right? This P0. Add 400 to each side. Add this one too. So you will have 400. Okay. So this is my N. What is my friction force? My friction force is this one, right? Times this. What is the mu s? 0.4 times 400 plus 0.5 times this one. Agree, everyone? So this will be 160 plus 4 times 2 will be 'Are you with me? Okay, so we got this one. We use this equation, right? We use this one. Now we can use this one. We want to find P. You see, F is a function of P. F of X. What is F of X? You see, F of X, again, F is going to be in this direction because we are going to move this part in the positive X, right? So it's very important to to have the right assumption. Okay. P cosine 30, right? That's positive. And this should be negative, right? Minus F, 0. That's all I have. I can continue. I can bring this one into this equation. P cosine 30 minus 160 plus point. What is cosine 30? Is it, let me, cosine 30. Cosine 30 is 0.86. Okay? I can add these two numbers. 8, 6. Zero. This will be 0.66 P divide 160 point 0.66. 242. 4. Right? So what happened here? We use this equation. Remember, for friction, write down this equation and then start using, one by one. So here I use, this Fy equation to find n. N came up with a, as a function of some number, weight, and my unknown p. Okay, I have it there. Then I use this equation, friction equation, to find, friction force. This is a friction force. Then I use, Fx with this, scenario to find, p value, because f was a function of p. So we have p here. We can find p, which is 242. What was the previous number when it was pure horizontal? 160. So it gives you some idea. When you have some angle, your force has some angle, the friction, you have to apply more force. The real life example will be, when you want to move a refrigerator or cabinet, if you apply force horizontally, you would need, less force. But if you apply, some force with angle, you have to apply more force. Go ahead.
So I don't get. So you have P cosine of 30 minus F equals 0, right? And then so the F never got in the right side of the equation. So did you just like
Come here.
You're solving for P.
Yes, we're solving.
It's the same variable of each one.
yeah? So like this right here, like how does this F not carry over?
Because we found F before. F is here. You see, F is this one.
Okay.
So we changed it, we substituted with this. You see?
Oh, okay. So you just plugged it in.
Yeah. Now this is a function of P, so we brought it here. So now we have only P in there.
Okay. Awesome. All right. Thank you.
Well, any other question? No? Was it you got question?
I can see all your numbers on the.
Oh, it's 242. Sure, yeah, go ahead.
When you move the
Could you come, Sean? Okay. So the next problem. Oops, I should have moved it. Now we have inclined, plane. This situation, we have to use the same, concept for this inclined plane, inclined surface, but there is one, trick, one tip that is going to help you to solve it. You should not use, the original XY coordinate. You should, rotate it. You should rotate your coordinate with respect to this, plane. Okay, your new x will be, parallel to the inclined surface. It's better to use this format, right? If you want to use this format, it's gonna make, your problem complicated. You can do it. There is no question, but it has, it's going to be challenging. So in this problem, it says we have a mass like this one has a 140 kilogram, and it was supported by this inclined, plane, and has a 30 degree angle. We want to find a P, a pushing force, and it's going, applying this direction, right? The coefficient of static friction is 0.4. So what is the question? The question is that find the P that is going to make, motion. It's going to start, pushing this part upward, right? What is that, minimum force? Minimum force. Okay, so, once you have this, right, you have to, as I said, inclined surface, use this, coordinate. So let me draw it again here. Your part is this one. X, Y. Do not use this coordinate, okay? No. Use this coordinate, X, and this is Y, okay? So this is W going down. What is W here? It says 140, right? kg. You have to find the weight, right? In Newton. This is mass. So my in 140 times 981, it is 1373. Okay, I can write it here. 1373. So my weight has angle. So I'm going to decompose it. Yes.
So what if the weight in this equation will be times it by the gravity, force of gravity for this problem?
Why we are doing it?
Yeah, why are we times it by 9.8 in this situation?
What should we do then? We need, force, not, mass.
Oh, okay.
Yeah. Always when you're, doing a static problem, you have to convert it to force. Force is Newton for the metric. For, customary, US customary, it is pound, right? So because it was, kilogram, we had to convert it to Newton. So this is 30. There are different ways to find, the x component, y component, right? Previous lecture we said whatever mass you have, multiplied by sine 30, sine that angle. That gives you the x force. 1373 sine 30. So this is my W in x direction. My W in y direction will be 1373 times cosine 30. Okay, I have this, and then I have P applied here, right? So you tell me, where is the direction of friction? We're going to move it, upward. Our intention is going to be, upward. So friction has to be going down, always against movement. So my F is this one. Okay. Now we can use, this equation. We have all the numbers. We want to find, P. Let's use Fy. Fy, we want to use it because we can find N. Right? Fy gives us N. And then we can use, this equation to find friction force. Right? 0. What do we have in y direction? Yes.
You have 1373 sine 30 and cosine 30 flip flop from the screen. Is that intentional?
Huh?
1373 sine 30 is on the x-axis for the screen, and that's on the y-axis for your example.
This is cosine, right? This is cosine. It's going down. No. This is, in x direction.
Oh, it's just that they're in different positions, so I was reading it.
Yeah. Oh, yes. So this is here. I, drew it this, but it's going to be the same, right? Okay. It's not going to make a difference, Okay. So Fy, what do we have in Fy equation? What forces? We have this force, right? W. 1373 times cosine 30. Positive, negative. My y plus is going up, so this should be negative, right? What else? I forgot to draw N. N is going to be the perpendicular force. Surface force, right? Plus N. My N is 1373 cosine 30, which is how much? 1189. Okay. So I have my, vertical force. Then I'm going to find friction force. What is friction force? Mu s times n. What is that value? 0.4? 0.4 times, that is going to be 476. So this is the maximum friction force. Right? So do we have the P? No. So we need to find it. Which equation? We use f of x. What do we have in x direction? F going this way minus f, right? And then we have P going positive. What else? Are we done? Minus that weight, right? 1373 times no sine 30. 0. That's all. So we have f, we can plug it here, 4, 7, 6 plus p. This is half, right? It will be 600. Let me make sure I don't. 1, 3, 7, 6, 6, 8, 8, 0. My P is 4, 6, 4, 7, 6, 1, 1, 6, 4. Is that the same number? Yeah, book has 3, but I got 4. That's all right. That's fine. So just a rounding number. Okay. So this is the minimum P. No, I need to apply to start moving the part upward. Okay? Question? I use only these 3 equations. This, this, this. Nothing else. Right? That's it. How about this, the next part? How about the value of P, in how much P, how much, what is the force of P you apply, but still your part is going to go down. There is no value that let's say you apply 100, your part, because of this weight, will still go down. That friction will not be enough, right? Okay. You apply P, but that P is not going to be sufficient to hold your part. So if it is not enough, what's going to happen? If your part, the P is not enough to hold it, it's going to slide down. If the part is going to slide down, and then, how about the friction force? The friction force is going to be going up or going down. This is very important. It's going to resist against motion. So in this situation, F changes. The F direction changes. In the previous example, because we wanted to move it up, right? The F was against my movement. Now the part is coming down. My F friction force has to be against movement. So previously it was going this way. Now it has to be this way. So make sure you have the right assumption for the friction force. It changes the direction quickly. So my friction force, that is the main point here. Where do you pick that, F? My N is again this direction. So I know my forces, sine cosine 30. This is sine 30. Okay. Again, use this equation, Fy 0. What do we have? 1373. It's coming from the weight, right? Cosine 30. And then what else? We have N 0. That's all, right? In y direction. My N, again, will be the same force. Cosine 30. It is 476, right? 476. Okay, that's the first equation. The next equation is friction. Friction. No, this should be, this is my friction. This is 1189. My friction will be 1189. That is going to be 476. Okay. So next part is Fx 0. What do we have? P in this positive going positive. We have F plus, right? 4, 7, 6. Right? What else? Minus 1373 sine 30. So it will be P plus 4, 7, 6, 6, 8, 8, 0. That gives me P equal 211. Yeah, it's just rounding, Yeah, 212. We trust you. Okay. So this is, the value where your part, if you apply less than that, your part is going to go down. If you apply, 212, and the previous force was how much? We find, to move it up was around 1300. 11. 1163, right? So if you apply a force between 211, 212, and 1160, your part, this is going to go up, right? It's not going to slide down. That means, it's going to stay. Okay, so now in the another situation, we applied 450, right? So we are between P 1163. We are in that range, right? So if you apply a force between that, we want to find the resistant friction force. Okay. So let me erase this part. When you have a force about 450, P is 450. Now you have to determine. We're going to find, what is the question? Find the friction force. It's important to have, again, the right assumption. Where is that, F? Is it going up or is it going to be going down? Right? So my P, because it's less than this, right? So because when we get to this point, my F is going to be opposite direction. My F will be in this direction. It's going to resist against movement. But now we are not in that situation. We are in this range. So friction is going to help us against movement. So friction is going to be like this. So P 450. Now we use which equation? We use Fx 0 450 plus F friction force minus 1373 sine 30 0. My F 450, this is 688. So my friction force will be 238. Right? This is my friction force. So if you have time, I have a class activity where we want to find, there are two problems. Yes.
How did you figure out which direction is going before you started the equation?
Because when is it that F is going to be in the opposite direction? When my part is going to move up, right? And how much force I'm applying? 450, and it is less than the maximum force, right? I have a similar problem. We have a block like this one. It has a P. We want to find out how much force is needed. It's very similar to part A of this problem. I want you to solve it. I want you to find P, how much force is needed to start moving this block upward. And another problem is the same, surface, but in that direction, in that problem, P is the opposite direction. We want to see how much force is needed to push this one downward, right? So in this problem, the friction will be downward. Friction force is downward, right? Against, moving the part going up, right? In this problem, force is going to be against, in the upward direction. You have to use, again, X and Y. Look, this is my surface. Use this X positive and Y positive, right? Use this coordinate. So you can pick your partner and 3 students per group. We're gonna work together or?